Constants of proportionality is another way of saying the slope. If you watched the previous video, we definitely touched on constants of proportionality. We talked about how you can see a relationship in both a graph and in a table, and plucking it out of a word problem as well. The main takeaway that you need to pull out of this is it's as simple as dividing y divided by x, or dividing in general. But if you can identify which is the numerator, which is the denominator, you will be fine. So general tips are dollars should almost always be the top number, and then you're dividing by something else. And then you could also count rise and then run, or excuse me, rise and then run. That's known as the slope by simply counting rise and run. So we'll do a couple practice problems, but we have done constants of proportionality in the past. A proportional relationship exists when you have the same quotient when you divide y divided by x. A proportional relationship will always fall in the form y equals mx, and you can determine what that m is, known as both the constant of proportionality and the slope. You'll use the word slope as you get further along in mathematics, but the constant of proportionality, also known as, again, slope, is as simple as either counting up and then down, dividing y divided by x. So when we have a table, even if the table is not filled in, we know that coordinates, which are always x, y, we can plug in if my x is 2, my y is 4, and the other one again are x and then y, my x is 3, and my y is 6. To find the constant of proportionality, or m, I can simply figure out y divided by x. Again, it's not x divided by y, it's y is on top, y is on top, y is on top, y is on top. So 4 divided by 2 is 2. You might say, well, what if I did 6 divided by 3? Well, as you know, you'd get the same number. So since you got the same number, which is 2 both times, 2 is the number that goes right there, y equals 2x. The constant of proportionality, also known as slope, is 2. We can do the same thing from other tables, where we simply just do y divided by x. Now pay attention because they might flip-flop which one's the y, which one's the x. So it's 3 divided by 1, which is 3, 6 divided by 2, which is 3, 9 divided by 3, which is 3. So that's the constant of proportionality, 3. If it was a different number, it's not a proportional relationship. It has to be the same on all of them. Not most of them, all of them. Again, y divided by x, so it's 2 divided by 4, which you guys all know is 1/2 or 0.5. And then 3 divided by 6, which is not 2, it's the same thing, 0.5 or 1/2. So the constant of proportionality, you can either say is 0.5 or you can say is 1/2. Be ready for either of those answers. Here's another table. We have y, notice that y is in the bottom this time, divided by x. So it's 2 divided by 1, which is 2, 4 divided by 2, which is 2, 6 divided by 3, which is 2, and 8 divided by 4, which is always 2. So it always is 2. The constant of proportionality in this example is 2. Now let's see what it looks like in a graph. If my y, which is up and down, is 2, and my x is 1, so it's up 2 over 1. That's this one. Now it's up 4, x is 2, so it's over 2. So it's up 4 over 2, up 4 over 2. 4 here, and then 2 there. You might be noticing a pattern. Did that one. Up 6 over 3. Up 1, 2, 3, 4, 5, 6 over 3. Up 6 over 3. You notice that every single time it's up 2 over 1. Let me do it in different colors so you can see it. Up 2 over 1. Up 2 over 1. So the other way you could do this, up 2 over 1, which is 8, 4, which is what I have right there. The other thing you'll notice is it always goes to the origin. But you'll also notice you could just count up 2 over 1. So if I go up 2 and then over 1, that's known as the slope or constant of proportionality. 2 divided by 1 is 2. If you have a graph, you can just count. So how do we find the slope, also known as the constant of proportionality, by counting? We count. How much does it rise? How much does it run? So we go from here, 1, 2, goes up 2 over 1, up 2 over 1. 1, 2 over 1. Not how many dots, how many lines. So 1, 2 lines, and then 1 line. Up 2 over 1. So all of these have a slope or a constant of proportionality of 2. Notice that they always go through the origin. Any proportional relationship has to go through the origin, or it is not a proportional relationship. Applying this concept to a word problem, you just need to have a better understanding, a good understanding of what type of variable you're looking for, what should go as the numerator, what should go as the denominator. Here's an example. On Thursday, Mr. Mitchell ran 4 miles in 28 minutes, which I certainly don't think I can still do. Probably maybe one day, but not necessarily anymore. The constant of proportionality is blank minutes per mile. Now, this example kind of feeds it for you. It tells you blank minutes per mile. So since I know we talked about unit rates last time, we can simply divide. We know it's minutes on top and miles on bottom, therefore it's minutes divided by a mile. So I could use the example they told us. It'd be 28 minutes on top and then 4 miles on the bottom. And I just do 28 divided by 4, which is 7 minutes per mile. If I made this into a table, I'd know that I'd have minutes and miles, and this could kind of help me understand this. If it's 7 minutes for 1 mile, because that's what the unit rate is. We found 7 minutes for 1 mile per 7 minutes per 1 mile. That means 14 minutes for 2. Of course, it'd be 21 for 3, 28 for 4, and we already know that is the example they gave us. We can help, the table can help us, or we can kind of use the 7 minutes per mile information right here to help us with these two word problems. How many miles could Mr. Mitchell run in 35 minutes? Well, I can certainly keep this table going and go 35, which would be 5. So in 35 minutes, it would be 5 miles. Or we'll learn how to use proportions later. If he ran 3 miles, how long did it take him? Using that same information, we know that the table says 21 minutes. Make sure you're labeling. Or we know if it's 7 minutes for every 1 mile, I could just multiply both of them by 3 to get 21 minutes for 3 miles. So it's 21 minutes for 3 miles. Here's another word problem, kind of in a table, and assuming we have a missing value. If we have a missing value, we could find the relationship and go from there. If we assume this is y and x, because time, here's another hint, time almost always goes on the bottom. There's a nice hint for you. So it's 24 divided by 4, which is 6. 36 divided by 6, which is 6. We know it's going to fit, so we'll find out what that is in just a second. But we also know that 54 divided by 9 is also 6. So the question is, 42 divided by 6 is what? Well, 42 divided by 6 is 7. That means this is 7 hours right there. The rate of change, which is the amount of division, 666, is 6 parts per hour. Again, time goes on bottom, so that's why hour is on the bottom of that fraction. 6 parts per hour because that's what I got. Not 7. 7 is how I determine, because 42 divided by 7 is also 6. So the rate of change is the same division every single time, 6 parts per hour.